Okay, Abhinav, let's proceed ahead with your technical scenario for fluid mechanics and turbo machinery.
Yes, sir.
For ONGC interview, right?
Yes, sir.
Okay, can you tell me how you use the second law of Newton for fluids?
Sir, second law of Newton is used as basically Euler's equation. If we only include the gravity forces and
Can you write the
pressure
second law
forces.
of Newton? How will you use it for solids and for fluids separately?
Sir, for okay, sir. Sir.
What is the second law of Newton?
Yes, sir.
Can you read it out?
Sir, summation of forces is equal to mass into acceleration is used for generally for solids. And for fluids, it is used as minus of del P plus rho G is equal to rho A for non-viscous fluids.
Okay. So this is how it is used, right?
Yes, sir. For viscous, we use Navier-Stokes equation, which also includes viscous forces.
Okay. Okay. Now, Abhinav, can you tell me if I give you a liquid jet?
Yes, sir.
With mass flow rate m dot, and
Yes,
if
sir.
you impinge it on some plate,
Yes, sir.
then what will be the force acting on that?
Sir, it will be the change of momentum, initial minus final.
All you know is the mass flow rate of the jet, velocity of the jet. So what will be the force acting on that plate, stationary plate?
Sir, it will be rho into Q into U.
And what is Q?
Sir, flow rate, volume flow rate.
Suppose plate starts moving.
Sir, then it will be rho into Q into V1 minus rho into Q into U. U is the velocity of the plate.
Okay, can you tell me something about Pelton wheel?
Pelton wheel is, sir, basically vanes are mounted on a rotating wheel. So that if the vanes are not mounted on the wheel and it is just a vane moving with the jet, then the mass flow rate which is hitting on the plate is basically the relative velocity with the relative velocity. But if it is mounted on a wheel, which is called a Pelton wheel, the whole of the mass gets impinged on the plate it is hitting. So that is the basic advantage.
What kind of various velocity components do you calculate on the blades of turbo machines?
Basically, there are three velocities that we use to make the velocity triangle. The blade velocity U, the absolute velocity of the jet, and the relative velocity of the jet. And further, the absolute velocity of the jet can be divided into whirl component and flow component.
So what is the this thrust? What is this tangential component of velocity? It's called whirl.
Whirl velocity.
What is this? Which component is that of absolute velocity?
The tangential component.
Tangential component. What is the significance of flow velocity?
Sir, it is basically calculated, used to calculate the flow. And in some cases, like the axial turbines, it remains constant.
And can you tell me various kind of angles which you use in the blades?
Yes, sir. There is theta, which is the vane inlet angle. There is phi, which is vane outlet angle. Both of these are angles are with respect to relative velocity, between relative velocity and the blade velocity. And then there is alpha and beta. These are inlet and exit absolute velocity angles.
What are impulse and what are the reaction turbines?
So impulse turbines, we use the principle of impulse, which is basically the kinetic energy of the jet is converted into finally the runner power. And in reaction turbines, impulse as well as pressure energy is converted, which is called.
How do you calculate degree of reaction?
The degree of reaction is the contribution of pressure energy in the total head that we have that we are using in the turbine.
What is degree of friction in Francis?
In Francis turbine, sir, it is. Should I tell you the formula?
No, just define.
Sir,
Just the value, not formula, but value normally I'm asking.
Sir, Francis turbine, sir. Sir,
Can you give some
I'm not
turbine
sure.
in which degree of friction is 100%?
Yes, sir. In some reaction turbines, if there is no impulse action, like Hero's turbine, I think.
Yes. What kind
Yes,
of
sir.
efficiencies do you calculate in hydraulic turbines?
Sir, we calculate mechanical efficiency, which is the shaft power upon runner power. And then we calculate hydraulic efficiency, which is runner power upon water power. And then overall efficiency, which is the product of these two. And then there is a generator efficiency and a plant efficiency, which is the multiplication of all these.
How do you define the specific speed of the turbines?
Specific speed, sir, it is the rotational speed when we are getting unit power and we have available unit head.
What is the significance of calculation of this specific speed?
Sir, it tells us if it helps us in choosing a turbine for a particular head and a particular power. Like for 0 to 60, we usually specific speed, we usually use Pelton wheel turbine, and then up to 300 we use Francis turbine, and above 300 to 600 we use Kaplan turbine.
Can you tell me some of the this dimensionless numbers which you use while modeling of turbines?
Yes, sir. So we use Euler's number, which is viscous force ratio of viscous force upon pressure force. We have a Reynolds number, which is viscous force upon inertia force. Opposite, sir. Inertia upon viscous force. And then we have a Weber number, which is inertia force upon surface tension forces, and Mach number, which is V upon C, and one more Fraud number, inertia upon gravity forces.
Okay, Abhinav, now this modeling, what do you understand by modeling of the hydraulic turbines?
The modeling of a turbine means that if we have to actually design a turbine for some particular purpose, we first make a small version of it, like scaled down version of it. So that is called the model, and the turbine we are making will be called the prototype.
How Kaplan turbine is different from Francis?
Kaplan turbine is their axial turbine, and Kaplan and Francis turbine is their radial, inward radial turbine.
So how, which turbine has more efficiency, reaction turbine or impulse turbines?
Efficiency, sir. I think Kaplan turbine has more efficiency than Francis turbine, as far as I can remember.
Okay, Abhinav, let me give you the feedback now.
Yes.
Abhinav, see, you have gone through the hydraulic turbines, that you have the knowledge of this. You could answer many of the questions, but keep revising it. Some ticklish question you should not falter, right? So
Okay,
Newton's
sir.
second law is the starting of this forces on these turbines blades. M dot into dV, that is in the fluid, because fluid you don't have concept of mass. This is a concept of mass flow rate. Mass flow rate is the density into Q, discharge, rho Q into V. That is how it comes. Right? And when it is the plate is moving, then relative velocity comes into picture. And from there you get the formulas, then Pelton, Francis, and all these come. So specific speed and some heads you need to understand. And modeling of these turbines and velocity diagram, they will ask you to make velocity diagrams of all these. So just to be clear about that also. Next time you go for fluid mechanics and this turbo machinery with me, right?
Yes, sir.
Okay.